Next example, an aluminum steel bar having a cross-sectional area of 0.5 square inch carries an axial loads applied at the positions. So something like that. Compute the total change in length of the bar if the modulus of elasticity is 10 times 10 to the 6th psi. Assume the bar is suitably braced to prevent lateral buckling. So, unsa may pasabot sa lateral buckling? Ang yambot pasabot ana is something like this. Para dili daw ni ma-happen sa bar. So, usahay ang buckling will be like that. Or usahay ang buckling would be something like that. Or it could be like that. So, depende sa mode sa failure. But since, according sa problem that we're not going to, or we're going to prevent the lateral buckling of the material, so that's not going to happen. Okay, and also this is equilibrium already, as you observe in this problem. So if we try to add this 7,000 and 4,000 to the right, together with the subtraction of 5,000 and 6,000 to the left, then this is balance. No? So, padung sa right na force is 1,000, then padung sa left na force is 1,000, 11,000 rather. So, 11,000 on both sides. So, it's equilibrium. So, it's not going to buckle. Okay. So, the same sa previous na itong gibuhat in our example sa axial stress, we are going to consider sections because in every material nato from this point to here, maka-experience siya og lahi nga mode of stress from this material together with this another material here because of the forces being applied. And also, lahi pod ang stress nga ma-experience sa diri nga material. That's why we're going to separate the stresses and at the same time the deformity of the material. So we don't know what will happen in the sections because the material might experience compression or tension. So if that's going to happen, then there's a different approach that we're going to consider. It may be in compression or in tension. Remember that compression and tension are both axial forces. So, okay, so without further ado, let's continue. Okay, ang buhaton nato is we're going to consider a section. By the way, I have already prepared a section. No? So as you can see, I have this section and this one and also this. No, so I have prepared that already para at least ready na. So I'm going to consider section AA. So how do I consider that? I will cut this one and I will try to consider the left section because this is simpler. So kanira ato makita sa ato ang free body diagram unless nga kung sa other side ka mo ni mo makita which is daghan kaayo. So para ma-prevent na, then might as well consider this portion, section AA to the left. And this is our section AA. As you observe, I have copied already the 6,000 pounds and it is going to the left. And as you observe, it's now imbalance. And what we're going to do is provide a force that will counteract the 6,000 pounds. And it's obvious nga the force should be padong sa right. And I'll call that a force A because that is under section AA. Okay, so using equilibrium equation, summation of forces horizontal will have PA is just equal to 6,000 pounds. And as you observe, the 6,000 pounds is pointing away from the system. So it is a type of what axial force. So this is, I'll just label this one as tension because the bar or the force is pointing away from this body. So pointing away. Na. So that's tension. Okay. Since na naman tayo axial force, might as well get the deformation. So let's get the deformation. Deformation under section A is equal to PL over AE for the section A. Now, so what is the P for section A? The P for section A is just equal to PA, and that is 6,000 pounds. How about the length of the material A? So the length of the material A, as you can see, from this padondara, this is 3 feet. So that's 3 feet, or that's 36 inches. So ako na lang siyang gi-inches kay ang modulus of elasticity is in pounds per square inch. Okay, and then the area also is in 0.5 square inch. Actually, it has a uniform area from left end to the right end. So we have a uniform area. And then the modulus of elasticity is 10 times 10 to the 6 psi, or that's pounds per square inch. So let's apply that. We can get now the deformation. So the formation of A is equal to, so the PA is, pila atong PA, this is 6,000 pounds. I-change ang kon kay murag dako ra kayo. 6,000 pounds, and then to be multiplied by the length. Length is 36 inches. So how did I get 36 inches, by the way? I multiplied 12 inches with 3 feet. No? So conversion. In 1 foot, there are 12 inches. Since namatay 3 ka feet, then you multiply the 3 feet with 12 inches. So that's 36. And then our area is in 0.5 square inch. Then the modulus of elasticity is 10 times 10 to the 6 pounds per square inch. So we can cancel out here the pounds, this pounds here, and then this square inch. So all in all, we'll get the formation. The formation for A is equal to, that is 6,000 times 36 divided by 0.5 and 10 times 10 to the 6. So we'll have 0.0432 of an inch. And this is for the deformation for A, or section AA. But this is not the final answer yet, because we're still going to cut the segments. So this is for the segment BB. So this time, it could either be to the left or to the right. So it's really all up to you, since ang makita nimo sa left is just the same with the right, duha ka force. So I prepared, by the way, the section considering the left section. And I copied the 7,000 here and this one. So this is here. Okay, so as you observe, 6,000 versus 7,000, it is imbalanced. So we need a force that will act counter to the 7,000, since 6,000 is just lesser. So 7,000 is to the right and 6,000 is to the left. So we need more, 1,000 more. No, so this is force under B, section B. So get it from summation of forces horizontal equal to 0. You'll have PB is just equal to 7,000 minus 6,000. So as I have told you ganina, we need 8,000 more pounds. Okay, and as you observe, the force is pointing towards the body. So therefore, the PB is compression. So it is compression. So kung ano lang nato iyahang stress, iyahang deformation. So deformation of B is just equal to PB, or ibata na to, something like this one. PL over AE. But of course, this is for section D. So atong ato jung specify diha. P is just equal to PB now. And that is equal to 1,000 pounds. And then for the L, or length, it has 5 feet length. So that's 5 feet. Or that's 5 times 12, that's 60 inches. So proceed ta with the area. The same gihapon ang atong area, 0.5 square inch. And the same po ang atong modulus of elasticity nga 10 times 10 to the 6 pounds per square inch. Okay, kung ano to iyang stress, it's now deformation due to, not stress, but deformation due to the section B. So this is now 1,000 pounds to be multiplied by 60 inches divided by 0.5 square inch times 10 times 10 to the 6 pounds per square inch. Then same gihapon ganina, we're going to cancel this out, pounds and the square inch here, so living inches. So deformity, or deformation at B, is equal to 1,000 times 60 divided by 0.5 times 10 exponent times 10 to the 6. So this is 0.012 of an inch. But this is not our final answer yet. So lastly, we are going to cut this segment or section. So I will cut this one here, and I will not consider the left but rather the right, since simpler ang atong figure. So that's section CC. And this is section CC here, 4,000. So 4,000 is imbalance. We need a horizontal force that will make balance the 4,000, and that's PC. Okay, summation of forces horizontal for equilibrium will have summation of force horizontal equal to 0. PC is just equal to 4,000 pounds. And kung lang sa nato yung deformation, so this is PL over AE for section C. So what is our P here? This is equal to PC, and that is 4,000 pounds. Then our L, pila tong L sa section C, 4 feet. So 4 feet, or I can rewrite that as 48 inches, di ba? 48 inches. And then our area here is the same, 0.5 square inch. And then our modulus of elasticity is that's 10 times 10 to the 6 pounds per square inch. Okay, substitute. The formation of C is equal to 4,000 pounds times 48 inches divided by 0.5 square inch times 10 times 10 to the 6 pounds per square inch. Magyapon makancel out si pounds o si square inch, leaving that inches. So the formation at section C, that's 4,000 times 48 divided by 0.5 times 10 times 10 to the 6. So you have 0.0384. inch. But by the way, we have the type of force here, PC, nalimtan ako. PC is pointing away. No, it points away from the body. Therefore, this PC here is tension. So, nanong ako din gilabelan og tension o compression because ato lang i-recall ha, whenever naatay body, no, and then we subject the body in compressive force. So may tabo kay mo shrink ang atong material, no, mo gamay, no, instead nga ingon ani siya ka dako pag una tungod sa axial force nga compression, ni gamay na lang siya, no. So ni shrink, meaning ang ato ang length kay ni decrease. Then whenever naatay tensile force, so whenever naatay tensile force, no, so ana, so may tabo sa atong material sa kani kay gibira man siya on both sides, mo longer ang atong material, no. So mo longer siya, meaning the length now kay mo dako na siya, no. So whenever naatay compressive force, ang deformation nato sa compression kay to be considered as negative in length. Nya ang deformation nato in tension, ang deformation mahimo siyang positive in length. So compression mo shrink, so maminusan ang iyang length. Nya sa tension mo expand, so maplusan ang iyang length. So unsay relationship na to ani? So it's going to be like this one. The total deformation of the material is equal to the deformation of section A together with the deformation of section B and the deformation of section C. Pero depende sa axial force nga naabot sa iyaha. So si section A, ang iyang axial force kay tension, therefore will bear positive side. How about si section B? It says here nga compression si section B, therefore minus. And then sa section C, it says here that it is tension, so plus. So the total deformation would now be deformation of A minus deformation of B plus deformation of C. Yeah, kopyahan na lang nato. Deformation of A is 0.0432. 0.0432 minus deformation of B 0.012 plus deformation of C na 0.0384. 0.0384. So the total deformation is 0.0432 minus 0.012 plus 0.0384. So the deformation is 0.0696 of an inch. And this is our final answer.